So you're going to have to turn in your spreadsheet, and it's okay to begin to start making your spreadsheet this way. You know what this data is. You've been doing the measurements. This spreadsheet should make absolute sense to you. So shouldn't this chart here. However, to someone else, this data really doesn't mean anything at all. And the real value of this is this may not mean anything to you in another month, 2 months, or a year. So when you come back to it, you may like to know what this is. So here we obviously some values. It's data. These aren't formulas. Here we see some formulas, but we don't know why we're averaging something or what's going on. We do see a result, and this result may be correct, but once again, not hard-coded in, so, I mean, what does that mean? So, in reality, when you're done, this sheet should look something more like this sheet. Where here we're looking at this is calibration curve data, okay? And obviously we're looking at concentration of something, parts per million, and then some counts. In this case, we can clearly see its fluorescence because the chart is labeled. Here we now have our unknown counts. Here we know that this is our K and this is our N for the calibration curve, which is, of course, a function. Here we can see this is the calibration curve list, and each of the data points is labeled, and that this is, once again, a function. Here we can see that this is the dev squared for ppm for actually figuring out the linear regression error. This is the average counts, or the average y. This is the unknown concentration, which is simply our unknown minus, our y minus b divided by m in order to yield our x. And then this is our error in the unknown concentration. Once again, it's in the formula. It's using the dev squared, it's using the average counts, it's using the m, it's using the correct value of standard error in y, as well as n, k, and the unknown itself. Here we see a summary table because, of course, we are summarizing, and this is a result specifically of the information right above it. Here you can see the chart is labeled. Normally it's y versus x value, or indeterminate versus determinate. You can see our y-axis is labeled as to what it is, and then the units, counts. If you're doing fluorescence, it's counts. On the bottom is what it is, it's concentration, and then what do you mean by concentration? Molarity, molality, parts per million, so forth. We have a trend line. Our values on the bottom are on the order of error of our data, as so are our measurements on our y are on the order of the error in the y. And here we have our equation. It's been made a little bigger, and of course there's no grid on this that was confusing it. So how do we get to there? Well, this is our previous slide again. So in the chart, we may see this little X over here. You're going to click on this. You can then start adding things as in your title. Whatever you want. You can double click on this and set the number to be the correct value you want. Let's say we want it to be a number, and we want it to have one decimal place. It can be the same with this. In this case, we'll want 3. We may not like the grid lines. You may like them, you may not. I hate them. I can remove them. You click on the data, then right click on the data, add the trend line. In this case, we're going to do linear. Display the equation and the r squared. We don't want to set the intercept to anything. Maybe make it bigger. And put in your title.